Have you ever wondered why in the monster manual it lists a number and then sort of an equation in the for the hit points? For example, it'll say 32 and then a paren and 5d8 plus 10. What does that mean? This video tries to explain that. The monster manual lists hit points in an unusual way that some people aren't familiar with. What the monster manual does is it lists an expected value and an equation that how it determined that expected value. So, for example, the expected value of a six-sided die is 3.5. Why is it 3.5? So a little bit of introduction to odds and probability. Table below shows the odds for a six-sided dice. I'm assuming that the die is not loaded, that it's a fair die. So the odds of rolling a 1 is 1 in 6. The odds of rolling a 2 is 1 in 6, and so on. The probability is the extent to which something is probable. If the odds in 1 in 6, then the probability is 1 divided by 6, or 1/6, or 0.166666 on to infinity. The formula that I list below shows how you compute the expectation for a six-sided die. You take the odds for each side and multiply by its the odds of it happening multiplied by its value. So it's 1 times 1/6 plus 2 times 1/6 plus 3 times 1/6, all the way up to 6 times 1/6. So you can refactor the equation, and it's 1/6 times the sum of 1 plus 2 plus 3 plus 4 plus 5. And if you do that on your little calculator, you'll come up with 3.5. Now that's the way you would calculate it for a four-sided die, for a six-sided die. If I want to do a 100-sided die, that's a lot of work, adding up all those numbers. Then there's actually ways to calculate it out. So mathematics gets you some interesting notation, and hopefully you don't have any real math anxiety, but I'll explain what it's doing here. So what we're doing is we're calculating what's called the expected value. And the normal equation from probability for the expected value of the term, if we say we're summing a series of die rolls, so the expected value of x is the summation from 1 to n of x sub I times p sub I, where x is the value and p is the probability. In the case of where the dice is fair, we know that the odds are always the same, so that they're always 1 in n. So that is, for all I in the set 1 through n, the probability of for I is 1 over n. So we can replace that in the formula, and we get p sub I in the formula. And so the expectation of the random variable x is the summation from 1 to n of x sub I times 1 over n. But we can simplify that even more by moving the common factor outside. So now we know that the expected value for a random variable x is actually 1 over n times the summation of from I equals 1 to n of x sub I. The sides of the die form an arithmetic sequence. They go 1, 2, 3, 4, 5, 6, 7, and all the way up to the number of sides. That's assuming that you've got a normal die. If you've got some really odd die where it goes like 1, 3, 11, 13, you can actually calculate it but you need to know how the mathematical formula for those to calculate the next number. But this summation is called the nth partial sum. And there's actually a formula for calculating the nth partial sum. It's assuming that it's a arithmetic sequence where the sequence repeats in a predictable manner. So it's the nth partial sum is the n, where n is the number of elements in the sequence that we're adding, times the sum of the first element and the nth element, all divided by 2. So we know that dice are numbered sequentially. That means for all I element where I is an element of the set 1 through n, a sub I is equal to n. This means the equation for the nth partial sum really simplifies. It means the nth partial sum is n times 1 plus n divided by 2. Now we can plug that into the expected value to replace the entire summation. So we know the expected value of the random variable x is 1 over n times n plus times 1 plus n over 2, or we simplify it, that the expected value is 1 plus n over 2. What this means is we can calculate the expected value for a 20-sided die. We take 1 plus 20 and divide it by 2, and we come up with 10.5. That's why we get the expected value of 3.5 for a 6-sided die by taking 1 plus 6 is 7, divide by 2 is 3.5. Now let's go back to the example that I showed at the very beginning of 5d8 plus 10. What this means is that we're going to roll we would roll 5 8-sided dice, sum them up, and then add 10 to the result. But we can calculate the expected value. The expected value of one 8-sided die is 1 plus 8 divided by 2, or 4.5. So the expected value for 5 8-sided dice is 5 times that, or 22.5. We add 10, and that gets us 32.5. Now the monster manual always rounds down. If you go into the player's handbook and see what happens when you add hit dice to players when you pick up a die, it always rounds up. I hope this explains how we get those numbers and how you could actually calculate them yourself. Hopefully I didn't terrify anybody with any math equations. If you enjoyed my video, please give it a thumbs up. I would love to hear what you think about this, and I encourage you to subscribe to my channel. Thank you.